Everybody, welcome to our third talk, which is on a slightly different subject, not robots this time, and it's for all your children.
Of all ages.
Older children. Is cheating on your maths homework with Mathematica.
And other stuff as well, actually.
And other stuff, but I'll let you
well,
tell you all about it.
To be really accurate, it's not so much cheating, it's definitely checking. Now, because I wanted to do some physics and astronomy and astrophysics for the Open University, I thought I'd revise some maths. So I've been redoing basically the maths first year at university, which is basically all revision and stuff. And I found this genuinely really useful to check your work. Those of you who've used Wolfram Alpha online, I was trying to do some stuff outright. You sit there and you're like, right, that is the right answer, but how did you get it? And you click on the button marked expand and it goes, you have to pay for this option. It's like, yeah. But anyway, so this is really much more about checking your maths homework than actually cheating. Now, the reason behind all this is you probably notice this is the absolutely, it's just come out the box Raspberry Pi screen. Nothing added, nothing taken away. Actually, there is something added, but I'll come to that in a bit. And people notice, what is this Mathematica little sign thing down here? I can't work. This is going to end up being bad, isn't it? So if we click on that. Now, this is actually quite useful because now it starts up. And the first thing you notice is I've now got quite a while to talk because it runs like a dog. We actually worked out earlier that if you buy a £1,000 laptop and you put the £1,000 worth of Mathematica software on it, you get more bang per buck than the free Mathematica on a £35 or £30 Raspberry Pi. It really is not a speed job on this. It runs very slowly. Also, the other issue is it doesn't have much memory on the Pi, so you can't have huge data sets. But if you're the sort of person solving the kind of problem that you would spend £1,000 worth of for Mathematica, you're not going to be running it on a Pi. You're going to be doing some really serious work. So this is why it takes quite a while to start up. What they've done is they've just compiled it for the Pi. They've put no effort into optimizing it. But look, hooray! Eventually, up it comes. Happy days. You get a little help screen as well. Okay, neat. Let's get rid of that. Now this is basically what I wanted to achieve in this. This is not the most obvious of user interfaces, like, what do I do? So, let's try some obvious things. Let's do 2. Find where the plus key is, there it is. We're going to do 2. Now the plus is actually in red now because it should be 2 plus something. It's gone back to black. Now you might think you press enter, so let's press enter and nothing happens. You go on to the next line, which is a bit tedious. Well, you actually have to press, this is just to get people started on this, you press shift and enter. It thinks about it, right, it's 4. Epic win.
Put 2 and 2 together.
Sorry?
You put 2 and 2 together.
Yeah, absolutely. Now that, okay, great fun. So what happens if we divide 5 by 15? So you get the mousey thing, head back up there. Oh, great. I'm going to so end up swearing by the end of this. It's okay. So let's do 5 divided by 15. What's the answer? 5 divided by 15.
3.
A third.
Same
thing. I almost made that mistake. The interesting thing is you say a third, and it actually does say a third. It doesn't say 0.333333333333. It actually says a third. So what it's actually doing is normalizing fractions. So that's our first cunning little thing it does. Now suppose we do 5 divided by 15. Go back there. Let's put some brackets in. You can never have too many brackets in this stuff because operator precedence is basically painful.
What if it's all brackets?
Well, yeah, it will do basic syntax checking for you. Chug. So we're going to do 5 over 15 and we'll multiply that by,
12.
by 12. Actually, it's a good call. Let's see when that comes up. Just start with that one, which is chug, chug. Oh, it means yeah. See what I mean about brackets? Got to be very careful to get them right on this. Chug, 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 chug. I was going to put them more. Oh, go to the right place. So we can do 12. Yeah, that's a good call. Actually, I'll give that a quick go. That's one of the things I should have thought of. So if we do multiply that by 12. We get 4, which is the right answer. It hasn't done any rounding errors. So we can actually make that any bigger. No, that's not what I want to do. File. No. Edit. No. Format. Style. Font. Well spotted.
Or size.
Actually, what does size do? Larger. Look, then what's it say? Size is Alt and equals, obviously. Right, let's just quickly Alt. Where's equals on this keyboard? There. Oh, hang on, maybe you have to go up there. Alt equals. No, it's probably for fonts. That's slightly annoying. Maybe you have to highlight it. Come on. It's not going to let me do that. That's not. Sorry about that. That's slightly irritating. But if we replace that 12 with, for argument's sake, 19 over 7, it will again do all the good work. Blah, blah, blah. Which is 19 over 21, which is fairly straightforward, right? Okay, so that's the basic stuff. I'm really sorry people can't read that. I'm not sure how we could actually get the whole thing to increase in size. Format, that's just...
There's a right button, right-hand corner.
Oh, well spotted.
See whether that'll do it.
Notebook magnification, way, we're on to a winner. 300%. Click. Yes! Great! So, we were talking about cheating on your maths homework. So like, right, what do we need some maths homework for? So I got, right, let's get the GCSE revision book. We got the A-level one as well. This is where it gets, and these are literally out of the book. So we're going to do a bit more of the more complex stuff. So that's the really tedious, fairly straightforward stuff. Let's do some actual proper algebra with this. So that's simple numerics, blah, 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 blah. But then it shows the interesting point if it turns the fractions into the standard form or canonical. What do you call it when it's reduced properly? See?
Non-simplified.
Simplified form. X. So, chug, 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 chug. Let's do a. Where's our arrow on this keyboard? I really should have checked that. Oh, there it is. A cubed times a squared. No, this is actually out of the book I've got here, which is, run it, a to the fifth, right? Now it then gets more. Let's actually take one that's actually straight out of here. Oh, also we can go up and do times a to the beep minus 2. You're getting the idea on this, right? This is embarrassing. Where's the minus key on this thing? There it is. Hurrah! Right. Algebraic simplification. You could also do, again, I'm cheating. I'm actually using the example straight out the GCSE book here, which is great. Let's look at the other. Oh yes, here's another good one. So that's all quite useful. And obviously in here you can have plus y to the x and all the rest of it. So let's have a look. Getting a little bit more complicated. What happens if you do 3 lots of, I don't know, a squared plus 2 sound good to people? Actually, let's do a squared plus 3a minus 6. And you, oops, might actually help you put the 6 in. I like the way it does the error highlighting, so the fact it's in red tells you you've missed something out. Hurrah! Let's evaluate that. And he goes, hasn't really changed. All it's done is reformatted it. Interestingly, I don't know why Mathematica has this bizarre habit of, we would normally say a squared plus 3a minus 6. You know, you do the highest powers first. For no reason at all that I can figure out, it likes to do the lowest powered ones first. Go figure. Well, that's not terribly useful, is it? What we'd like it to do is to expand that. So we do expanding that, right? By typing expand. And just to confuse matters, they use square brackets. Mathematica, for some reason, oops, wrong button. Mathematica, for some reason, has this real thing about liking capital names at the start of functions, and it uses square brackets. Whoops, that's going to be on 2 lines possibly, so let's just go. It's like Python in liking end of lines. Gotcha. No, I haven't. Damn it. Oh, poo. Let's see if I can get a bigger target on that. Actually, see, that just works. You might realise it's wrapped. Ask it to expand. Yes, there we go. So that's quite useful. That again is an example straight out of the book. This is giving you, if you do expand, it basically multiplies out brackets. They've got another example is that rather than just doing the 3, we could sit there and go boink, doink, doink. Let's do 2a, oh, let's get awkward, plus x. What could go wrong there? And again, you ask it to evaluate. Woo, that's a bit mean. So that expands out quite complicatedly, but you can see it does actually do it for you. We would actually make that 2a plus 3, or 4 will do, it's near enough, for large values of 3. Then again, you can see how, you've got the general idea of what's actually going on here, yeah? Now, of course, maybe you want to do all that the other way round. So you've got the expansion, you want to factorise it. If you want to factor something, strangely enough, you say factor. Factor, open brackets, 2x squared, I don't know, I'm just making this up, minus 3x. This is probably going to use horrible, horrible numbers, plus 3, close, shift, enter. Right, there you go. So this is your basic algebraic manipulation. Now I find this incredibly useful because frankly I'm rubbish at multiplying, and the thing I lost most marks on in my first year university mathematics was this plus and minus stuff. Apparently they're different. So I consistently produced, or consistently lost marks, so being like plus blah 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 when it was minus blah blah blah. You know, minus times minus times minus. Turns out it's minus, not plus. Which you do some huge complicated bit of integral calculus and you make that mistake at the end. Yeah, welcome to my life.
Sorry, that doesn't seem to have factorised it, was it meant to?
It could, that's why it's not that.
Oh, well done, yes. Let's think of one that actually does. Sorry, well spotted that person. 2x squared minus 3x plus 3. Yeah, it can't factorise it. Let's...
They've got a few equations that can't
So it's
factorise.
not into complex numbers then?
It is actually, but he just didn't want to do it in that particular case for some reason. Whoops, wrong button. Let's think, what can we factorise a bit easier?
X squared plus 5x minus 6.
X squared
No, that's the one I remember.
plus 5x. So I should have checked the maths before. This is the mistake of pulling numbers out your head. Minus 6.
Yeah, that's factorable.
Okay. Yay! That's what it meant to be like. Live demos. This, by the way, is why you don't do live demos, for those who were asking earlier. Right, so that's factoring stuff. Fantastic. Blah, 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 blah. This is why this is actually a really useful to use this as a prompt. Solving equations. Fantastic. So we've done factorising. This is again straight out of all the GCSE stuff. Solving equations. Strangely enough, you do that by calling solve. Who would have figured that one out? So we've actually got, I'm going to make a mistake on the syntax at some point. So the example that is in the book here is 5x plus 4. Other key things in here is for equals, like in some programming languages, you need to use the double equals, because single equals means assigned to, which is actually mathematically irritating in this. We've got 5x plus 4 equals 8x minus 5. This is pretty straightforward GCSE typey stuff. Now, the thing is, actually, what happens, let's just try putting that straight in. I'm suspecting it's going to whinge at me. Oh no, there we go.
I beat it.
So that, but this is why it's useful, right? Because if you're doing this, you need to show the working in exams. But I find this incredibly useful for actually checking. It's a very simple case, but you can just check with that. The reason why I was slightly surprised it worked is that solve typically takes 2 parameters. The first one is what you want to solve, and the second one is the variable you're solving for. So you could sit there and say, solve 5x plus 4 equals 8x minus 5, comma, x, meaning, and I want x is what I want to know. But it's figured out there's only one unknown, so it's dropped that one through. Happy days. Now, if we've done the whole rearranging formulas type nonsense, very common, they love this kind of stuff, which is actually incredibly useful. So you can use it again for that. I'm actually using the examples from the book, so this time will actually be solvable. So this is actually, and you still use solve for this. Dong, 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 dong. Oops, open. So what they've actually said is you've got u equals 4v squared plus, there it is, 5w. Whoops, missed out the 2, thank you. That would have been embarrassing. Whoops. This little mobile keyboard thing is jolly good unless you actually have to type. Right, now that, if you just type it in, is like, what? So actually, what happens if I do here? Pure amusement. Oh, yeah. Oh, actually, that solved it for w. Which, strangely enough, actually they wanted it solved for v. Wonder why it solved it for w. But we want to make v, so we can sit there and put comma. Oh, good grief. Sorry. We want to make v the subject of that is the question. So basically solving that equation for v. And off you go. Jog. So we've now got v equals plus or minus half of the square root of u minus 5w. So that you can use a double check. I think it ought to use plus and minus signs. I'd find that more convenient, the plus minus symbol. But this is your basic rearranging of equations. So everyone's sort of happy with that so far? This is basically a very brief tour of this. And it can also do the whole, you can do factorising, quadratic, so actually we'll keep, you're getting the gist of this sort of stuff, right? So that's reordering an equation. Solve just about solves anything, because you basically, it's very good at actually figuring it out. So if you've got, I'm going to use an example that's actually got, we've got x squared minus x. Oh, thank you. Oh, good grief, this is going to kill me, this keyboard. X squared minus x, choke, whoops, that one, choke, minus 12 equals 0. Classic quadratic equation. I'm actually not going to put the x in on the end. We'll see if it actually manages to figure out that's the only thing it can actually solve it for. And x equals minus 3 or x equals 4. Okay, this is still pretty GCSE stuff, which frankly you would never spend £1,000 for what the full version of this software costs, or thereabouts, $1,000, lots. But this is just going through. It's very useful to check those answers. You have to show you're working if you're doing this for real in school, of course. But to sit there and realise that you haven't got the sign the wrong way around, I would, being fairly typical me, I'd have said x equals 3 or 4, and I've got the minus sign missed out. I'm always making mistakes like that. It's really useful for that double check at the end. Oh, now we did the whole, actually we did factorising, haven't we? Yep. Blah, 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 blah. Blah, blah, algebraic fractions. Oh yeah, can also do all the other fun things. This is winding back a little bit, but I'm just doing it in the order it's in the book, so that's actually quite convenient. I'm basically sticking to the GCSE syllabus on this, because that's quite nice to look at. We can do stuff like, and that's also the audience I'm vaguely aiming at. This is 21x to the power 3, y to the power 2, close bracket, divided by open bracket, 14x. You had to put the times in as I found this, times y to the power 3. Otherwise, if you just put in xy, it assumes you've got a variable called xy. If you put in x times y, it's variable x times variable y. So if you put that in and ask it to evaluate it, it simplifies it down. This is very useful. Again, you're supposed to work all this stuff out, but I am personally appalling at making stupid arithmetic errors in the middle, getting the signs wrong, this sort of stuff. So just chugging through and doing this sort of stuff is really useful. This is all really, really simple basic stuff, but I wanted to prove it. And that is pretty much algebraic fractions. Yeah, it can do stuff like that. That's pretty much what we've already covered. And graphing. Okay, and that basically is pretty much most of GCSE algebra, I think. Unless anyone can think of anything else I've missed out.
Is it do graphs, isn't it?
Ah, graphs, yes. Let's do graphs. Graphs are fun, actually. And this is another interesting point. I'll show you why in a minute. Doink, hang on, no, doink. It is very good at drawing graphs. So, plot. Inevitable open square bracket. What do we want to plot?
Can you put a couple of things on the same screen? So x squared.
Oh, okay.
Equals y.
Oh, we've got awkward people in the audience. Excellent. So, let's see if I can remember my Mathematica syntax. This is going to be horrible, which is great fun. We also use a system called Maxima that I might drop in at the end, which is another similar system, plus side free, plus side much, much faster, minus side 40-year-old piece of software, but still going strong. It's one of the original mathematical manipulation pieces of software written, in the 60s, I think, originally. Written in Lisp, interestingly enough, going back. We were discussing Lisp earlier, and there's a talk about it later. So you want us to plot two graphs at the same time. Right, and I'm going to do this as a live demo without having rehearsed it, which, as everyone will tell you, is an appalling idea. Mathematica, as you point us to some of the answers, it puts curly brackets around things. Curly brackets means a list of things. So we want to plot. Open square bracket means this is the parameters of the plot. Open curly brackets means let's have a list of things. So, Sam, what would you like plotted?
X squared, y equals x squared.
So we want x squared. And anything else?
And y equals x.
And x. The y is actually kind of implicit. And what particular range do you want for that?
100 each way.
So x goes from, if I get this right, it'll be a miracle, minus 100 to 100. Close curly bracket, close square bracket. Can you sort of follow that through? And this is the point where we hit enter. Please be syntactically correct. Now, the important thing to notice at this point is what's going on down here. This is the bit where we generally play Girls from Ipanema and go, because this is where I meant what I meant earlier by not being blindingly fast.
Should have done smaller range.
It's
So it makes no difference, it's viewport window, isn't it?
Hey! Now, I can't resist this next bit. Sam has provided us with some rather awkward stuff here. You can see the nice plot of x squared in blue, and I've got to admit, it took a while to do, but that graphical output is rather nice quality. The x squared goes up to like 10,000, whereas the x, which is the orangey browny line on the bottom, isn't really doing an awful lot. So what we could do is knock the range down a bit. That's because the x squared so vastly dominates the x, it's like pushing that x line down. So what we could do is you could do x squared, oh, let's be awkward, minus 2x, whoops, where's it? Oh, I've done x squared there. Let's put minus 2x plus 6. Plus 6, come on, do it. Oh, no. Plus, oh no, there we go, 6. And we'll knock the range down a bit as well. Boom, 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 boom. Oops. Yes, okay. I think I might be slightly...
The cookie positive, though, is it?
Well, we'll see what that actually does. And again, run it. Right, that was massively faster actually. But yeah, you can see the plots of the graphs there. That's actually quite useful. And at this point, you've actually plotted all this stuff. Actually, I have to wind back a bit. On the maths course I was doing, we had one of the assessments. It said, sketch a graph off. And immediately it's like, well, actually, it was actually email because it's over the internet. I said, like, sketch? What? You know, you mean with like pencil on dead tree? He said, like, yes, no computer graphics, you're going to have to learn to do this properly. It's like, blimey. But one of the things in here that is well worth noting is we go up here, file, I think, get this right, hopefully. You can save as, is it save or is it export? We'll find out in a minute. You can, don't want to save it as a Wolfram note, but you can actually save all the work you've done, which is all good. But you can save it as PostScript and PDF, so you can get all that's on the screen and put it out as a PDF, which you can then edit out. What I do, being like the whole uber geeky, for those of you who are into it, there's something called LaTeX, which is a really high quality mathematical typesetting system. And I did that, exported it into LaTeX and posted that in my maths assessments. But you can actually save that and print it and all sorts of fun stuff. Go away, cancel. So, graph plotting, as requested. How long have I got?
You've had a red flag for the last 5 minutes.
Excellent. So that is a very brief overview. I didn't even get to touch the A-level second. It can do integration, differentiation, it's vast bound. There's these entire thick books, this thick, on what you can do in Mathematica.
It's a shame it costs so much, isn't it? It's really sad.
This is the free version.
Yeah, I know, but it only runs on a Pi. You do anything complicated and it takes ages to calculate. I mean, it's obviously a lost leader for Wolfram.
Oh, absolutely, yes,
It's
yeah.
always been an incredibly expensive piece of software, and it's so good.
This is actually a key point. This is actually just to actually finish on. It is very, very good. This is without doubt the leading software in this field. It is without doubt the most expensive software in this field. It costs an absolute mint. The Pi version is not only incredibly slow, but you've only got that limited amount of RAM. You might want to be doing, actually it's in the Institute of Astronomy, you might have some data on stars, say 100,000 stars, and you've got brightness versus this, all sorts of, big data is what we're talking, and you want to analyse the big data. It's not going to happen on a Pi. It really isn't, which is why, as you say, it's a lost leader. There is something else in there called Maxima, which will do everything that I've done, is free, is much, much faster, and is free on Windows, Mac, Linux, blah, 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 blah.
Yeah,
So, yes, that's basically it. I'll be around for questions afterwards. It can do a lot more of the whole integration, differentiation, all of the much more complicated A-level maths. In fact, it'll actually do beyond degree level maths quite. That's what you're paying your money for. They charge such an absolute fortune for it because it is that leading piece of software. This just gives you a taster. But the big plus is, I think its graphical output, or its drawing of graphs, is just gorgeous. You can also do 3D graphs and all sorts of funky stuff. Right, I better leave it at that before
Yes, you
Tim
have.
lynches me.
Yep. Well, thank you very much, Jim.